Welcome to the Fast Mode podcast series. I'm Tara Neal, and with me today is Susan White, AVP of Strategy at Netcracker. Netcracker Technology, a wholly owned subsidiary of NEC Corporation, has the expertise, culture, and resources to help service providers around the world transform their businesses to thrive in the digital economy. In December last year, Netcracker was named the winner of the OSS and Automation Leader Award for Performance at the Fast Mode Awards 2025. Welcome, Susan. Great to have you on today's episode.
Thank you, Tara. It's great to be here.
Awesome. So, you guys won big at the Fast Mode Awards last year. And I know that, the award was for OSS and Automation Leader. So let's see, how does the team feel about being named as the winner? And we know that the solution that won the award was Netcracker's domain automation solution. So, maybe you would like to share a little about how the solution sets, you guys apart from others in the industry.
Absolutely. Well, first of all, we're really delighted to receive the award. It's a great recognition for the work we've done in transforming OSS from basically, what was a heavy, manual, very complex environment to systems that are now extremely agile and really can adapt in real time to the different needs of the business. So what sets us apart? Well, there's a few things. First of all, I'd say what we do is make sure we tie the network to the business. And that's incredibly important because if a fault happens, of course, we know how to fix that fault. But what we also know is the services that are impacted and the customers that are on those services and the SLAs and the contracts that they've signed up for. So doing this allows, better decisions to be made and faster decisions as well. And we're actually doing this in some really complex environments too, not just telco, but also new low Earth orbit satellite networks. For example, one of our customers, Telesat, they have a really complex environment with huge amounts of dynamicism. And obviously these, satellite. So satellite is extremely costly. So the ability to link what's happening in space and the terrestrial network to their customers and SLAs and prospect customers is really critical to make the business work. So that's one thing. The second thing, we've really built our domain automation solutions to predict what's going to happen in the network. So to get ahead of the game, if you like, and start to fix things before customers even know there's an issue. And that's because, we've closed the loop with AI. So we built AI models that can predict when thresholds are going to be breached, and therefore an SLA will be out of contract. And we can therefore, with our solution, be able to automatically find the best resolution and, get everything back on track. And the third key thing is probably the blueprint solution that we built. And a good example here is what we did with Swisscom, because in any domain of the network, whether it's transport, core, RAN, fiber access, and even now satellite, there's a lot of commonality between these different domains and a lot of tools that can be shared across teams. So with Swisscom, we built a blueprint, but we also offered it in the form of IT as a service to their own internal teams, and that really massively reduced the time to deploy new domains from what was 1 to 2 years to about 6 months now. So big difference.
Wow, that sounds awesome. Like, to summarize what you just said, you guys, through the domain automation solution, you bring visibility, like what you rightly pointed out. It's not just fixing the fault, but knowing, what's SLAs are impacted and customers who are impacted. And I think it's quite remarkable that, you cover the complexities of the satellite network. And, we hear a lot of talk about, the terrestrial and non-terrestrial networks coming together. So I guess this is where the solution really wins. And of course, predictive capabilities using AI, that's definitely something that, will benefit operators of all kinds. And yep, the Swisscom example is definitely something that, a lot of operators can go with. So, from there, in your opinion, how autonomous are today's telco networks in real deployments? Because we hear this a lot, but we want to know, really how autonomous they are, and what are some of the key challenges?
Okay, so I guess the simple answer is most of them not very autonomous today. There's an awful lot of automation, absolutely. We've been automating tasks across the OSS network for many, many years. We have predefined workflows, predefined service models. Even for assurance, we know things that happen all the time and have defined, predefined fixes, if you like, for those problems that happen. But real autonomy, where I guess what we're saying now is systems have to make their own decisions, they have to create their own workflow on the fly, they have to implement them. Not many. I mean, absolutely, there's some telcos that are much further ahead here, and certainly for some use cases. I think there's a number of operators around the world that are moving in that direction. But it's the scale. I think scaling that across the business is still hard. And if we think about the issues, it's not just technology. Of course, technology is part of it, and we'll talk a few things there. But it's one of the issues we find is the organization. And many telcos are not really set up to benefit from high levels of autonomy because they have a sort of very horizontal, like very, very large teams within the OSS environment, maybe a mix of old legacy and newish systems. But the problem is the speed to get things moving. Like if they want to introduce a new agile way of working, like build a DevOps pipeline, for example, for new capabilities and features, getting that implemented across these teams usually is just impossible. Or not impossible, just takes a long, long time. So we find that the operators who are being the most successful are those that really break their organizations down to small, self-sufficient teams that have clear ownership for a piece of the network, like maybe a small domain. And then they can move fast. They can make their own decisions and they can implement the technologies that they need to be successful whilst benefiting from, sharing across the different groups. So that's one. I'd say the second is very obvious. We talk about it all the time. It's the data issue. OSS is such a complex environment, a lot of different systems, many still old systems, but now mixed in with the new. And a good example here is inventory. Inventory, it's really the keys for autonomous networking, because you have to have and know everything that you have in your network, if you like, as a minimum. It has to be correct for AN systems to use or AI systems to use. But many operators don't have that yet. They're still, they still haven't modernized that inventory and cleaned it up. So that's a key issue that many have. And maybe the third one is AI itself, because whilst we speak a lot about AI, and absolutely AI is needed to get to high levels of autonomy, and that's fundamentally because we just have so much complexity in the network, so much data. We're not, have not short of data, but making sense of that data is difficult to make the right decisions. So yes, we need predictive AI, we need agentic AI, but many telcos struggle, particularly with agentic AI, because it's such a new area, to introduce and scale it. And obviously it's also about, but what's the security you need to put in place, and how do you trust that if you use this new technology it's going to give you the right answers, and how do you govern it? So they become, I think, some of the major stumbling blocks to move things forward.
Mm-hmm. Wow. I guess, when you talked about the challenges, you brought the organization first, and I think that shows the kind of priority. When we are talking about what sets some organizations ahead and what creates the laggards, in terms of adopting or autonomous networks. So, and you rightly pointed out about the data issues, and the AI itself is really interesting. And, when you talked about, agentic AI in particular, I know that this is a big area. It's an emerging area. Everyone's talking about it. So we want to hear more, about this. So what do you think is the role of agentic AI in autonomous networks? Especially, where does it add value, and is it essential to achieve full network autonomy?
Well, as you say, this is a really big area right now that everybody's working towards, and it's a really important question as well. Where and when is it needed? And well, if we step back a little bit, I guess just to be clear, Agentic AI introduces the concept of agents. And these agents work with large language models or small language models as appropriate, and other tools to basically take on tasks and figure out themselves how to do those tasks, just like a human would. So we're moving away from these predefined scripts. But one thing I would say about agentic AI is it can have value at any stage of autonomy or automation an operator may have. It's not just about those higher levels. And I think what it does is it's we need to think of it in terms of these agents having multiple roles, and where a number of operators are starting with what we call assist agents. So these agents are assisting engineers to do things faster. Could be interacting with inventory systems to get information on live ports, or it could be finding a root cause in the network, or creating the new configuration in a fraction of the time, or creating a service design. All these things are helping humans do their job faster, and in some cases maybe helping them be more accurate as well. So even it doesn't really matter what level of autonomy you have. You could be running a reasonably basic network. These agents can already add value today to help you, automate some tasks and move forward. But agents can take on much more than an assist role. This is just the beginning. I think the view is certainly the view we have is agentic AI is not. It's not really a quick fix for automation gaps. It's so much more, because what we're moving towards now is fundamentally changing the operating model, and that means operations will actually become agent led. So yes, agents will still always assist humans. That won't change, and humans won't disappear. That's for sure in operational tasks. But the agents themselves will take on more autonomous tasks, and work together with other agents. So, for example, agents will not just detect a fault or even then automatically find the root cause, but they will figure out how to fix it, and they will implement the fix. Now, all of that can be done without humans stepping in. You still have human oversight. But if needed at any stage, you could opt out and say, look, human has to give the approval for the next stage. So it really depends. It'll be that sort of level of autonomy that will increase over time as telcos get more comfortable and trust the technology and trust that it's giving the correct answers. But over time, and this will be over time, we see agents being more embedded in the operations of the business, not just assisting humans. But, and this is the big but, the big issue that we have to consider is these large language models that are powering these agents, whilst they're incredibly powerful, and will continue to get more powerful over time, they have no clue about telecom. They don't know what's in a telco network. They don't know how everything relates. You can't just pull out that information from inventory or other systems. It's way more complicated than that. So basically, and one more thing, actually, they don't even reason. I mean, a lot of people talk about LLM's reasoning, but they actually only simulate reasoning. They don't actually reason themselves. That's not what they do. So when you're talking about mission critical operations, things that can literally pull down your network and put, many industries out, lose billions from many industries, that's not an option anymore to be incorrect. So you need other capabilities to augment these LLMs to help them make the right decisions. It's not all on the LLMs anymore, but it's the surround environment where you need what we call like a telecom intelligence layer that basically links these great models with the telco network and provides all that knowledge of what's inside and and how everything links together. And every telco network, unfortunately, is very different. So they're all quite unique. But this middle layer is becoming incredibly important to move forward to the very high levels of autonomy with agents, and just regular automation technology.
Wow, I think you brought some really interesting insights. The first one, when you talked about how, regardless of the size of the organization, it can somewhat benefit from agentic AI. You don't need to grow your, autonomous levels to a certain levels before getting or embedding agentic AI. And the second point that you said, the level of autonomy that one wishes to have basically depends on how deep you want to embed these capabilities. So we are looking at a lot of flexibility there that organizations have if they understand agentic AI, the way they should. And then but then you rightly also pointed out some really critical things that a lot of people should be aware of. The fact that there are some gaps there in the LLMs themselves, in the models themselves, because like what you said, reasoning capabilities and also familiarity with telecoms. And I think this is so interesting, the telecom intelligence layer. That is something that a lot of operators would need to understand, that you need a level of intelligence that's based on the telco environment, the peculiarities of the telco business. So these are really really very interesting. So back to Netcracker's solution in this space, the domain automation solution, right? So how does it essentially help operators bring autonomous networking to life?
So I think a few things, and perhaps before we talk about the solution, one of the things we do up front is really sit down and understand the business needs of why what the operator wants and what value higher levels of autonomy can bring to their network, like how you can measure it, what foundations need to be in place, what's the return on investment, and essentially how to make that business case work, which is where things can get really stalled. I mean, it could be the case in some operator environments, they only have a few services, they're fine. In other operators, they're really pushing the doors of innovation and their business teams are struggling because the network can't keep up. And that's where it's important to figure out up front, what is it you need to do and why, and can you justify it before you get moving. So that's a very, very important point we start with. But then we basically leverage our expertise in this domain automation because we've built commercial solutions for every domain, of which there's a very common piece we call this blueprint approach, this common domain automation blueprint, which it really speeds up, if you like, the ability to introduce these new capabilities into every operator environment, and AI can be added at any stage. So that piece we talked of a bit earlier is critical. But we've also predefined many AI agents as well that are ready to go, and these can be ones that again can perform this assist role. And can help with areas of the business right now, because even in an operator environment, they'll all be at different, even in their own network, they'll have different parts of the network. They're at different stages. So some parts can be very advanced, others can be quite lacking. But you can also orchestrate these agents together in any way to increase that level and take on more and more tasks and be more and more autonomous as you get that trust. So that's a key thing. I'd say the other one is the important thing you pointed out that I mentioned earlier, which is this telecom intelligence layer. It's really, such an important part. It's the keys between, agentic AI just being a little bit of added value, a few extra features, if you like, to fundamentally improving the business and changing how the business runs. That's the difference this can make. And certainly in Netcracker, we've been in this business for 30 years, so we know networks, we know how everything's put together, we know all the business processes. They have to be redesigned for AI, of course, because they're not built for humans, and in the future. So we know all this. This is why we can, we have the tools and graphs and capabilities to pull all these things together with knowledge bases, with vector databases, with ontologies that do all the relationships in the network, to a very deep level, through to reasoning tools that can help agents understand what safe actions to take, so that if they're trying to fix a fault in one part of the network, it's not going to create 10 others somewhere else. And that's very important too. So, and then the final piece I would like to say, because this is probably one of the most important ones, is we put in a major focus on governance and security, because with the introduction of AI and with the network becoming more and more autonomous, this can't happen without understanding what's going on, what the agents are doing, are they correct, how they work with each other, who has priority, and being able to have humans roll back and step in and stop whatever's happening at any stage that they want. So that part is incredibly important, and all the inherent security along with that. So that's kind of the big things that I guess are our focus here.
Wow. I think this term blueprint approach that you just said, I guess that is unique to Netcracker, is it?
Yes, absolutely. This is something we've built from many years of working this strategy with many operators, and putting together the blueprint, if you like, and the shared tools and environment that helps the solution be replicated very fast across the business.
So it's like a secret formula, I guess. That's you
Exactly.
got. Okay, your secret formula. Okay. So yeah, I mean, yeah, we can appreciate that. I mean, anyone working in this area would know that the level of, expertise and intelligence. The second point that you mentioned. How much that makes a difference in the real, in real implementations. This is not just like buying a model and just integrating it and letting it run. It's knowing all those things, and like what you said, having the guardrails as well. So this really gives a full picture of what's in store if you are trying to play with AI and autonomous networks. So, yeah, I think that's one other thing that we wanted to know. You did mention about satellite networks, so that's an old area, but it's re-emerging as a major area because like what you say, the terrestrial and non-terrestrial networks are coming together. So, so which emerging areas do you believe will drive the adoption of domain automation in a big way? So, like satellite networks and so forth.
Exactly. So I think, yeah, satellite networks for sure. I mean, they've really, I mean, we've been using satellite for so many years, but it's never been that exciting technology. It's always been a backup in telecoms. It's been something we might get, our TV services through, but it hasn't had that buzz. Well, now it does. I
Yes,
think,
finally.
yeah,
Finally.
and I think that's very much down to low Earth orbit satellite, and obviously the success of Starlink, and the capabilities it can bring, and that sort of opened the door for a whole new era of communications, because the reality is low Earth orbit satellite can have very similar service capabilities to fiber in terms of latency, and bandwidth. Just depends how many you put together. And in the past, it was super costly. You couldn't really do it. LEO's been around for decades, but it was just very complex. But But now with the, SpaceX and others, launch rockets that are available, we can put many, many, many small satellites together. It's changed the game in terms of pricing. So it suddenly is emerging, I'd say still emerging, but it's emerging as a sort of more mainstream area of telecoms, and not just kind of a backup. And a lot of work's happening right now to do direct to device, where we can, now we're used to flipping from Wi-Fi to 5G or 4G. Soon we'll be flipping from, satellite will be in that mix too. But you won't see the quality of service difference. It won't be for emergency calling like Apple do today. It'll be for any service. So yes, but these satellite networks are hugely complex. I mean, one of the big customers we're working with is Telesat. They're building something that's really for the business and wholesale market. So their whole focus is on very strict SLAs, in fact, multiple SLAs as you pass across the earth. And these domain automation solutions are essential because the amount of complexity involved in this, and the ability to make sure that you keep that service up and running when you're talking about multi-domain now, including space, and making sure that those very high-paying customers don't get any issues, you don't breach their SLAs, will be critical. But not just LEO, even GEO is moving to software-defined GEO. So we have a number of customers there too who now want to vary the bandwidth. They provide for different types of services, and even GEO is becoming quite complicated and needs these domain automation solutions to adapt and react fast to the different service needs. So satellite, a huge area. Obviously, lots happening in telecoms as they branch into more vertical industries, more edge compute, AI inference at the edge, all these new capabilities, slicing, dynamic slicing, of course, that's not quite materialized yet, but will be. These will become huge markets for these domain solutions.
Wow, something that started with, just maybe 2G, 3G networks, is now, expanding. It's the breadth of it is simply, it can be so overwhelming, right? And these kind of solutions are what pulling these different domains together, I guess.
Exactly. No, we're in a very exciting era.
Exactly. Okay, awesome. Well, I guess, Susan, that brings us to the end of our session. So thank you so much for joining us today and for sharing these insights. It's great learning more about Netcracker's domain automation and how it helps operators achieve complete closed loop automation across so many different domains. So thank you. Thank you so much.
Thank you very much, Tara.
And to everyone tuning in, thank you guys for listening. If you want to learn more, visit www.netcracker.com and follow us for more updates and insights as we continue to uncover the latest in technology and telecommunications. See you in our next session. Bye-bye.